And once again, disproving for all statements is way easier than proving because there's a finite example. Now let's do the harder one, actually proving. So let's say, for example, for all A in the set 0, so it's not a very big domain, but it's a domain. And then for all B in the real numbers, A times B equals 0. So is this true or false?
This is true, right? Anything
Obviously.
times 0 is 0.
Obviously true, right? We're not really doing anything too special here, right? And here's the proof for it. So once again, right, I'm going to call it Q squiggly of A, right? So the predicate of this universal statement is Q squiggly of A. And so to prove for all statements true, we have to use method of exhaustion. So let A in 0, then A must be 0. For there's more than one thing in the domain, here's the part where we go like, if it was like 0, 1, 2, 3, you'd say A must be 0, A must be 1, 2, or 3. Those are options. If A equals 0, then consider B and the real numbers. For every B in the real numbers, A times B equals 0. Thus, for all A and here, and B and here, A times B equals 0. All right. And by the way, this hopefully seems really simple, really obvious, like nothing special happened here. In here, we just kind of did our first direct proof. We'll talk about that later. But anyway, yes, this is the point behind double universal statements. It's to prove that for everything in the first domain and everything in the second domain, it makes the predicate true. So proving it, there's really no trick. It's just prove it always works. Good. Moving on. Making progress, making our way downtown, walking fast.